Passage 4, page 173. Questions 14 through 19. Listen to part of a lecture in an astronomy class.
The giant impact model, or theory, as it is described in the media. This hypothesis explains a lot of things about the Earth-Moon system and about the composition of the two bodies. Now, we're going to delve a little deeper into the model itself in a minute, and I'll put up the pictures. But let me just explain the model in brief and give you some of the evidence in support of the model. Then, I'll provide you with evidence that does not support the model. That will finally lead me to my primary point in this lecture, which is why I'm calling this a model and not a theory. So, the idea is that soon after our solar system formed, there were a lot of planet-sized objects orbiting around the Sun, some of which were orbiting at the same distance from the Sun. As planets began to acquire greater mass, their stronger gravitational fields began to disturb their orbits and send some of them smashing into each other. The giant impact model postulates that a planet the size of Mars, called Theia, was one of these doomed planets. Oh, and incidentally, Theia was named after the Greek Titan, believed to be the earth goddess of sight and the light of the sky, who gave birth to the moon goddess Selene. So there's a bit of trivia for you that I personally find very fitting. Whether you think it's clever or not, you should be thankful. Certainly the name Theia is more suggestive and memorable than the series of digits and letters that are sometimes used to name outer space objects. So, anyway, back to what I was describing. And you know what? Let me just get this picture up now, because it'll make more sense. I was going to wait till we started talking about the math involved in the model, but you might as well see what I'm describing. Okay, so here you can see it. Theia crashed into the object that would become the Earth, the proto-Earth, at something like a 45-degree angle, vaporizing, completely burning off the outer layers of both planets and sending the iron core at the center of Theia into the core of the Earth. Then, very quickly, some of the material that had been vaporized and blown off came together again on the Earth, and some also formed into a ball that became the Moon. So, both planets would then have been transformed into molten hot liquid balls, with the Earth retaining most of the iron cores of both the proto-Earth and Theia, and the Moon being composed of the outer layers of rock from the crash and much less iron. One of the first bits of evidence used for the giant impact model was this difference in iron between the two. When the Apollo astronauts brought back samples of moon rocks and data, they indicated that the Moon does, indeed, have much less iron than the Earth. This evidence actually predates the giant impact model, and it was this observation that got people thinking about what could explain this difference in the first place. Now, why does the iron core matter? Well, it turns out that without this extra massive iron core, the Earth would not have the strong magnetic field that it does. And it's this magnetic field that deflects a lot of the Sun's harmful radiation away from the Earth's surface. So, life on this planet would have developed quite differently, if at all, had it not been for this protective field. And the iron core matters for other reasons, but I'm getting more off topic than usual here. Another piece of evidence is the computer model of the giant impact itself. The fact that you can calculate various collision scenarios using the laws of physics and tremendous number calculating power, I mean that you can get exactly the results that this hypothesis predicts using the computer model. This is evidence in and of itself. Now, before you go swallowing this whole story hook, line and sinker, let me qualify some of the evidence that might change your mind. And that will lead me to a point about theories. There is, in fact, evidence that does not support the giant impact model. For one thing, there is no evidence that the entire Earth was ever a giant ocean of molten hot liquid rock, as this model predicts. Now, there are several other pieces of evidence that support the model, but I think it's safe to say that the evidence is not overwhelming enough to call this a theory. But the specific point I want to make right now has to do with the difference between a theory and a model, or a hypothesis, as these terms are used by scientists. You see, most non-scientists think that a theory is a hypothesis, or a guess about the world. This is not true at all. In order for a hypothesis or model to qualify as a scientific theory, it must explain what has been observed and tested repeatedly. That does not mean that there are no problems at all, or no mysterious phenomena that seem to defy the theory. In general, minor irregularities do not disprove theories, but instead define gaps in our knowledge, gaps that may eventually be explained by later evidence or developments of the theory. So, okay, to apply this to our current model, the giant impact model, not theory, though it may eventually be called that without question, explains a lot of what we understand about our Earth and Moon. However, it does not explain everything. If we find further evidence that does not support the model, we may eventually be forced to reject it. On the other hand, if evidence continues to accumulate and further explanations are found for any irregularities or anomalies, eventually most people will accept the model as accurate, and it will then, without doubt, bear the title of theory.